Assalamu alaikum. How are you?
Sir. Hello,
Can you
sir.
hear me?
Yes, sir.
Okay. I'm sorry that I forgot to create a Google Calendar link. That's why you need permission to access. But let us go with it. So, okay. So we have our makeup class today. And this is the second last class. Tomorrow is our last class. So probably we will finish our syllabus by today, and in the last class maybe we can discuss some of your questions, confusions about the final syllabus and in different chapters. Okay, so in the last class I think we have covered a very important concept in data link layer, that is ARP. We have also covered different categories of media access control protocols, like uh, channel partitioning, random access, and then finally taking turns, right? And also you have covered ARP, address resolution protocol, that will get a mapping of IP address to MAC address, because we need MAC address to physically send a packet or frame bit by bit, converting into signals to the immediate next node. Okay, now let us get some overview about ARP. There are two cases. In case one, the network is a single segment network where there is no router. There can be different number of switches and hubs, and in this case every node is physically connected to every other node through hubs or through routers. In that case, the destination is within the network, right, and directly reachable physically. So in this case, uh, ARP works with broadcasting ARP request to everybody, and only the node that matches with the destination IP will reply the message ARP reply, and then the source will store that MAC in its ARP table. So if you give ARP-A command in your command prompt in your PC or laptop, you will get the ARP table for that particular PC. And second category was when we have multiple networks separated by. So this was ARP protocol in action for a single segment network, and ARP always works within a network. And then the second part was when the destination is in a different network. Doesn't matter whether there is a single router in the middle or there are 100 routers in the middle, the idea is same. The source will hand over to the destination, as to the router, the packet to the router, and then router will do the rest. So using ARP, we will never need to know the MAC address of a destination that is in a different network. Okay, so these are the two cases we have covered in the previous class. Anybody has any question in this example or any other topic that we have covered before we move to the last section that we will study? No question? Okay, so this is probably 6.3.1, where we will read something about the learning of an Ethernet switch. I think by this time you know switch Difference between switch and hub. Basically, hub works in physical layer, switch works in data link layer, but there are some exceptions. But we will uh, take the basic one. Switch is a data link layer device. So that means switch will work with MAC address. Okay, and it takes an active role. It will store and forward the Ethernet frames, like router stores and forwards the network layer packet. Similarly, switch stores and forwards the data link layer packet, that is called a frame. And how switch works, the basic idea is very simple. Examine the incoming frame's MAC address and then selectively forward the frame to one or more outgoing links when frame is to be forwarded on the segment. And also switch uses a protocol called CSMA-CD to access the segment. Okay, so CSMA-CD, we have given the idea. This is a random access protocol. But what is most basic feature of switch? It will send the frame only to the destination. So that means many simultaneous connections can be going on using the switch. That's why switch performs much better compared to hub, because hub can transmit one connection data at a time. Okay, and also switch is transparent to the hosts. When a host, very important point, when a host A wants to send data to host B, as I have mentioned several times, how we can start the communication? We start with the IP address of host B, right? So finally, when host A sends the frame to host B within the same network, the switch will not change anything, not the IP address, even not the source and destination MAC address. Switch will only forward the frame to the correct port where host B is connected. So switch will change nothing. That means since switch change nothing in the frame, the same frame host A sends will be received by host B. That's why it is called transparent to the user, transparent to the host, because there is nothing changed. It's plug and play. You know, plug and play. Just you connect, it will work. And it is self-learning. Just understand the logic. Initially, when you just configure the switch, or you just switch or shut down, you just switch on the particular switch in the network, then it will do some initialization. Okay, at that time, when there is no table, forwarding table of the switch of IP to MAC, MAC to particular port is not created, in that time switch works like hub. In that time, but that's a fraction of seconds, within which switch creates its own table, and after that it will always work efficiently and will transmit data to a particular host connected to a particular port. Switches do not need to be configured. Actually, there are different level of switches. Some are manageable switches, some are unmanageable switches, some needs more configuration, but basic configuration is not needed. Whenever you connect to the switch, it will work. I think many of you have worked with wireless router, right? Wireless router, basically 3 devices in a single physical device. It is a router, it's a switch, and it's an access point. Okay, so switch means you can use the LAN port. Anybody use the LAN port of wireless router?
Yes,
Anytime,
still I'm using, sir.
right, Mainul?
Yes,
So you have used the LAN port to connect a wired line to the device. Sometimes some devices don't have that wireless interface, right? Maybe my PC, I
yes,
can add in wireless interface to my PC, but if that has only the wired interface, that means the RJ45 cable, so in the Ethernet port, so in that case, that will not work for Wi-Fi. But Still, I can use my wireless router to connect to my PC using that, where connected to the LAN port of the wireless router. You could see there are possibly 3 or 4 LAN ports and then one WAN port. WAN port is connected from the ISP line, that is the internet line, and then LAN ports can be connected to the internal devices. So you can use Wi-Fi, at the same time you can use wired LAN. So that means why? Because there is a switch built in there in the wireless router. Okay. Okay. Now how switch works? Switch can support multiple simultaneous transmissions. As you can see in the diagram, there are 6 ports in the switch: 1, 2, 3, 4, 5, 6, right? And there are 6 devices connected to the switch: A, B, C, and then A prime, B prime, and C prime. Ports have dedicated direct connection to the switch. So we have mentioned it during the start of this chapter 6.1.1, where we have said switch actually when we connect a host to a switch, that is a bidirectional connection, so it can simultaneously send and receive, and also it's a point-to-point connection, so there is no possibility of collision. And but it can happen, suppose multiple nodes send data to C prime, to the same destination node. Okay, in that case you have to forward all those frames to a particular port. Again, this is a packet switching thing, so each port will only transfer one single frame at a time. So if more frames coming up, by the time it transmits one single frame, then the other frames will be queued up. It will buffered by the switch of that particular port. And Ethernet protocol used on each incoming link, so there will be no collision. As I said, there will be no collision because it's a point-to-point link. It's a full duplex, that means bidirectional communication. And we can you can say that each link is its own collision domain. Okay. Now see, both communication can happen here. That is not possible in a hub, right? A to A prime and B to B prime, they can continuously transmit simultaneously, because there is no collision in switches. But A to A prime and C to A prime cannot happen simultaneously. So what will happen? Tell me, what will happen in this case? A to A prime, B to B prime. So there is no common node, right? Destination is different. So that can happen simultaneously if nodes are different. But A to A prime and C to A prime means both A and C is transmitting to A prime. It cannot happen simultaneously. Then what will happen in this case? Any idea?
Buffer.
Right, very good. Buffer. Because it will not discard, it will not drop. It will buffer in a queue. So in which port? The port where destination is connected, A prime is connected. That is, you can see port number 4. So every port in the switch is a device that has also buffering capability like router.
Sir,
Pratik, you had a question?
yes, sir. Sir, my question is that, sir, A to A prime sir hobe sir, but C to A prime কেন হবে না sir?
Which one? C2,
Sir,
A to A prime and C to A prime. See, the destination is same, right? So you cannot send multiple packets to a destination. As I said, in packet switching, in chapter 1, what we told, only one packet at a time can be transmitted in any link, right?
yes, sir.
So if multiple packets coming to A prime, that means what? Switch cannot send multiple packets at the same. Switch will send one packet, but what will happen to the other packet? That is the question. What will happen to the other frames?
Yes, sir. Got it,
As
sir.
Muhib said, yes, those will be buffered. Which port? Every port will have a separate buffer. Okay, so at port number 4, the packet frames will be stored there and then sent one by one, no problem. It is clear?
স্যার আমি যদি C2A তে পাঠাই তাহলে কি ওটা বাফার হবে?
No. In that case, because see, when it is buffered, when there are more frames, then the port can process one frame at a time, right? So if one frame to a node, another frame to another node, another frame to another node, no need to buffer. Then it's not a problem. But when multiple frames, the destination will be the same. In that case, only one frame at a time can be sent, so other frames will be buffered. So this is actually not the logic new in this chapter. This is the logic always in packet switching, because in packet switching only one packet or one frame can be transferred at a time. So if more than then the capacity arrives, then the rest of the packets will be buffered, and then if the buffer is full, then the packet or frame will be discarded, dropped, because buffer has a limited capability memory, right? Okay.
Yes.
Okay, now let us go through a very basic example. How does switch know a prime reachable via interface 4? That is a good question, because we will never configure that a host MAC address is connected to port number 4. We can, but normally we don't do that, because if you just make it static, then if you change some other nodes, then it will not work. So basically what we do, we don't configure this. Switch will automatically run. That's why it's called self-learning. Now the question is, how does switch will know A prime is reachable via interface 4 and B prime is reachable via interface 5? I can see from the diagram, but switch is not seeing from the diagram. How switch understands? That is the question. So what happens, you can see each switch has a switch table that is called MAC table. That is called MAC table because it stores MAC address to a corresponding port or interface. That's why it's called MAC table, it's called switch table, it's called forwarding table. See, we have forwarding table for a router in chapter 5. But now when we say forwarding table for a switch, that is actually this MAC table. Okay, we'll see how this look like. Each entry has a MAC address of the host and the interface to reach the host and timestamp. See, interface to reach the host, not interface to which the host is connected. But the idea is same. When you use a single switch, right? When you use a single switch, in that case, you can say, okay, C is connected to 3. But when you use multiple switch, then one switch is connected to another one that is connected to a probably, maybe. And in that case, maybe C is a node that is connected through a different switch. But for the current switch, that must store the port or interface to reach that host. How switch knows that? We'll see an example. Looks like a routing table, but this is not with IP. This is only with the MAC address. How are entries created, maintained in switch table? Something like a routing protocol. So this is the question. Let us wait to find the solution to the question. But now understand the question first. How switch self-learns to propagate, to actually create this switch table? That is the question. Now we will see a detailed example now. Suppose again this switch, just assume switch has nothing. You just connected the switch to the network. You just started the switch. So the table is empty. Assume. Now switch learns which hosts can be reached through which interfaces by its self-learning capability. How? For example, host A sends a frame to host A prime. You can see the source is A and the destination is A prime, right? Okay, can you tell me what type of addresses are these? A and A prime? Is this IP address or MAC address?
MAC address.
MAC address.
Right, MAC address, because we are now dealing with data link layer. Data link layer deals with MAC address. But we have to consider this as a frame. So frame contains a packet and packet header contains source IP and destination IP. But in this case, switch will never work with IP. Switch will work with MAC address. So A is the MAC address of host A and A prime is the MAC address of host A prime, that is destination MAC. Now A will send, because A is connected to port number 1, so A will send the frame to switch actual destination is A prime, but it will go through the switch with port number 1. That is very much visible here. So what switch will do? So see, initially the table is empty. Okay, initially the table is empty. Then, okay, before we start, when we host A sends this frame to host A prime through switch, is it possible for the switch to know that host A is connected to port number 1? Yes or no?
No, sir.
Definitely yes, right? Is it possible for the switch to know A prime is connected to port number 4? Yes or no?
Yes, sir.
Actually, in this case, this is no.
सर
See,
नो हो गए
right, because when switch receives a frame at port number 1, and in the frame the source MAC is A, switch knows, okay, A is connected to port number 1. But think about the A prime. The MAC of A prime is destination MAC. That switch knows. But how switch will know that is connected to 4? Because switch is not receiving anything in 4. Clear? So switch can only be sure when it receives a frame with a particular interface, because the source MAC is connected to that interface, definitely. But it is not sure about the destination, because destination can be connected to anywhere. If that is not stored in the table. So initially, what switch will do? See, when frame receives, switch learns location of the sender, not the receiver, because it is not possible to know the location of the receiver, because it only received from the sender. So it's MAC A connected to 1. Sure, everybody confirm? Any question? If that is confirmed, then switch will store that entry in the table. So switch will store like, okay, MAC A is connected to my port number 1. Very simple. And there is a TTL. As I said, TTL is a time, how much time that entry will be there. So if a particular machine is disconnected, for example, A is disconnected, how long switch will store that entry in its MAC table, because that will use up its memory, right? So that is the TTL value. Don't worry about the TTL value right now. It can be a default, it can be configured. Then records sender location pair in switch table, that is fine, but no idea about the destination. But it will search for the destination in the table. It will search, okay, whether A prime, information about A prime is in my table, yes or no. If no, that is one thing. If yes, then it will use that interface. But in our example, is there any entry for MAC of A prime in the table, MAC table,
Yes,
or
sir.
switch table? Yes or no?
Yes, sir.
No, sir.
No, there is no entry about sorry about A prime. There is entry about A, just we have added now. There is no other entry. See,
Oh,
it was initially empty. So that is the case. If destination is not sorry, it is repeated, destination is not in the table, then another decision switch needs to make. Okay, that is called flooding. Is it clear now? Because there is no entry about MAC A prime, switch knows nothing about A prime. So how switch will work? It will work almost similar to hub, but this is for the first few seconds. By the time the table is actually created, then switch will work more intelligently. So in this case, since there is no entry about A prime, we call the action will be flooding. Okay, is it clear? That means switch will send to every interface only except interface 1, because this interface, it received the frame, so it will not forward this interface. Okay, now A prime gives a reply to A. Okay, So now what switch will do? We need to define two things. What switch will do? What will be the state of the switch table, number one, and number two, what will be the action of the switch? Both you have to answer. Now A prime sends a reply to A. First question, what will be the change in switch table? You can use your message box. Yes, define. Muhib.
A prime will be in the table.
Very good. A prime will be in the table with the corresponding interface. Now, because this reply is received using interface number 4, port number 4, so switch will store this, right? So this is the way how switch actually learns the MAC table. But we are taking so much time to make you understand, but actually it happens in fraction of seconds in the real case. Okay. Again, everybody, I want to participate. Everybody should participate, and then if you have any question, you can put in the message box also. And if you want to participate using the answers, you can also use your message box. Okay. So what will happen? Two actions. First thing, change in the table. So A prime will be added. Okay. And then the second action, see, selectively send on just one link. Why? Anybody? Why it only?
Sir,
right, because it is already in the table. The destination is now A. Is it in the table? Yes or no?
Yes.
Yes.
Sir, how long it will be in the table?
That is the question. In this case, it's 60. That means, for example, it's 60 seconds. But there is a default value. There is a value you can change. Okay. But TTL defines how long it will be there. And if there is no actually interaction of host A, then after this time, it will delete this entry. But for the time being, we need to know how the table is changed, and secondly, how switch will act. So if the destination MAC is known, then switch will act intelligently. It will not send to everybody. It will send to only to the destination. But there is one exception. I think we have mentioned in ARP. Can you remember that in ARP in ARP request, what is the destination MAC address? In ARP request, what is the destination MAC address? Can you tell me? Anybody? When ARP works, the sender sends an ARP request, not the data frame. And in that ARP request, it incorporates the IP address of the destination, and it incorporates a destination MAC, because destination MAC is not known. So what was the value there? All F, right? All F, that is binary all 1. Why? Because that is the broadcast MAC address. So in that case, the destination MAC will be all F. So in that case, although switch knows everybody's interface in the table, still it will broadcast that frame to everybody, only if the destination MAC is all F. Okay. Otherwise, it will selectively send on just one link. If the destination is not known, it will flag to every other links if the destination is not known. So there are two possible options only in case of switch table update, in case of action also. In case of switch table update, if there is already there, no update. If that is not already there, update the table. In case of action, if there is already there, selectively send. If that is not there, flag to all other interfaces. So that is how switch works. Any question? Okay. We'll do some hands-on examples. But before that, this is the section 6.7. I told you there is an example, a day in the life of a web request. This is nothing new we are learning. We have learned many protocols, And this example in the last section of chapter 6 in the book, textbook actually gives you a synthesized example. That is, if we use an example to review the concept of the protocols we have learned already. So this is the example. So if you go through the example, if you think now at the start of the trimester, we have given the similar example, but we said don't worry about the details right now. Just think about how the example works, right? During the start of the trimester. And at that time, I have also mentioned this thing that at the end of the trimester, we will go through the example again, but that time it should be crystal clear to you what is happening. It should be visible on top of your head what is happening inside. So if we still are not sure what is happening inside, we have very our concepts are not very good. If our concepts are good already in this course, then we should be able to see every details in this example in our visualization. Okay, so that's why this is very important, and I might ask questions in the exam based on the understanding of this example. So don't take it lightly. This is not a new thing. Already we have learned things and we are just applying those things here. Okay, now what is the example? We have covered now application layer, we have covered transport layer, we have covered network layer, we have covered data link layer, although we did not go very in depth of physical layer, but we have concept of physical layer in from other courses. So the concept, our journey has now complete, and putting it all together, we need to again see a good example where everything is there, and to know that okay, I have understood the things. The goal is to identify, review, understand the protocols at all layers involved in this seemingly simple scenario, and that is every day, not only one time. Every day you are doing this many times in every day. Requesting and web page, right? Browsing, we are doing continuously. And the scenario is student attaches laptop. For example, you went to UIU permanent campus, and then you opened up your laptop, so that is connected to the Wi-Fi, connected to the campus network, and then you are browsing google.com. So this is a very simple case. I think many of you, all of you have actually done this. So use this as the simple example to review our concept app layering. So a day in the life, the example scenario, you can see school network. So this school network, you can think about this is, sorry, you can think about this is our UIU network. School network means university network, UI network, although UIU uses 10 dot something, right? 10 dot. So it's class A network, but here it says 6882.0, doesn't matter. Then this is the ISP network. Comcast is the ISP. For example, UIU takes internet connection from I'm not sure to current ISP, but this is the ISP name. So if UIU takes it from Bangladesh Online, that it will be Bangladesh Online. Okay, network, and they have their own network with the corresponding DNS server. Okay, and then this is the lowest part is the internet. So it's there is a web server. You can see maybe it is Google. Oh, okay, that is the Google's network, right? That's the Google network, and the Google network, all the servers in Google is here. So this is the example scenario where we have our UIU network, we have the ISP network through which UIU is connected, and you can see the router connected to the ISP router. So this router we can call the netted router. Probably net is configured here, okay? And then ISP router, and then there are many ISP routers, and then there is a Google network where the server is. Is the scenario clear to everybody?
Yes.
Okay. Now let us move. So arriving mobile connection. So you go to the UIU network, you connect it to UIU network, and then UIU, you opened your laptop, connected, and then you opened your browser and then give the address www.google.com. What will happen first? Sounds very simple, but we need to know everything inside now. Can anybody tell me what will happen first?
It will
DNS.
convert the DNS and IP address.
Very good, very good, very good. Yes. First we need to get the IP address, because in Wi-Fi normally we configure DHCP. Okay, DHCP means dynamic IP address, not the static. So first it needs to, because the scenario says we have chosen a scenario where all the protocols will be there. Did you implement DHCP in lab, in the network lab?
Yes, sir.
Yes.
Okay, so you have also the knowledge of DHCP. So when we open the laptop, because our IP is not statically fixed, first it needs to get a IP address, and it's through DHCP. So UIU has a DHCP server, maybe router is the DHCP server. Router, you have configured router as the DHCP server in the network lab. So initially DHCP protocol will work. How it will work? If you go through the internet protocol stack, then application layer protocol is DHCP. DHCP uses UDP, transport layer. Then it uses a network layer IP, then Ethernet, and then physical. Okay, so this request will go through the DHCP server, and in this case router is the DHCP server. Okay, and how DHCP works? DHCP request encapsulated in a UDP segment, that is encapsulated in an IP packet, that is encapsulated in an 802.3. The 802.3 means wired Ethernet protocol. Okay, so it's a data link layer protocol. That means it's a frame, and then the broadcast, and then the Ethernet frame broadcast, all F, we have mentioned this, all F will be used as the DHCP request. So everybody in the network will receive, but only the DHCP server will respond. And then if DHCP server responds, it will offer a particular IP to the laptop, to the device that requested. And then finally it will confirm, okay, I am using that IP. So now your laptop got the IP. Okay, now you are ready to browse the internet. Next step, definitely DNS, because we are using HTTP, but before HTTP can be packet can be created in network layer, we need source IP and destination IP. Source IP is there, no problem, but destination IP must be known through DNS, because we have given google.com, so it must get the corresponding IP of google.com. See, all the protocols we have studied so far. Just in any case, if you have any confusion, please ask me, or if you think, okay, this is not covered, please ask me. So everything we have covered so far. So DNS, again, DNS works based on UDP, and then the network layer, data link layer, physical layer is similar. Okay, one more thing here is we need to use DNS, but if you can see, the DNS server in this case is in a different network. So what the laptop needs to do, it needs to forward the DNS request to which? To the router, right? To the default gateway. In that case, it needs to know the MAC address of the router's interface. So where ARP comes? Now see, before DNS and before HTTP, ARP comes. So again, you have to also know the order of protocols we need to follow. You cannot send an HTTP request without knowing the IP address by DNS. You cannot send a name to IP address request, that is DNS request, without knowing the MAC address of the router. If the DNS is within the network, that is very unlikely, then you don't need the router. But if the DNS is in the ISP's network. Also, if you think about the DNS in the UIU network, the local DNS, that is in a different network. That is not in the same network as the clients are. Okay, so both the cases we have to transmit the DNS request to the router, right? So that's why we need ARP. So ARP comes here. Again, ARP, after ARP is complete, that means now router knows the MAC address of the router. The host knows, laptop knows the MAC address of the router. So now it can create the DNS query. Okay. So DNS query is created and it will be sent to the router because DNS server is in a different network. Okay, sorry, before DNS, it needs to complete the ARP. So ARP query, ARP request, and then ARP reply. So this is also just we have studied in this course. Now, one significant thing here, everybody, please observe one significant thing. Exactly when ARP is actually requested. See, already we have started the DNS query. So after DNS query reached the IP network layer, that is a DNS query in a network layer packet. Okay, now we need to know the MAC address of router because DNS server is in a different network. See, because the IP of DNS server is in a different network. So it needs to send to the router. To send to the router, it needs to know the destination MAC address of the router as the destination. So see, when DNS query is in the network layer, the data packet shown in red, green, and blue, that is as it is, that is kept as it is, because the data packet cannot be converted to frame until we know the destination MAC address. So that's why keeping data packet as it is, it starts an ARP protocol by broadcasting ARP request and receiving ARP reply. Now in the ARP reply, it contains the destination MAC of router, right? Can you follow me? Yes or no?
Yes, sir.
Okay. See, if you just go through this example with a bit of determination, I think all the confusions, all the gaps in your concept will be much more clear now, because it shows you every step what is happening for a simple web request. So after ARP request is actually done, only then the DNS request packet can be converted to a frame with the destination MAC of the router. So that is the data frame. See, now the data frame is created. So that is DNS query. So DNS query will be sent to the router. See, IP datagram containing the DNS query forwarded via the LAN switch. LAN switch means in this case actually a router, to the first hop router. First hop router means that will be connected to the next router. So DNS query is forwarded based on the routing. You have also implemented routing in the network lab, so I am not going through routing here. See, RIP, OSPF, IS, any routing protocol. All the routing protocols will help to reach this DNS query to the correct network in the internet where the DNS server is. Now DNS server reached the DNS query. It will process the query like this, and it will reply with a DNS reply, DNS response. The DNS response will contain the IP address of the google.com. Okay. Okay, just one more thing. So just assume this DNS query has been reached by the laptop where it gets the destination IP. Okay, and then DNS is done. So now laptop has IP address of the google.com. Now what? Now we come to HTTP. So see, we have learned in HTTP when we click a particular link, we said, okay, an request is created and HTTP request is sent, right? But in this case, we've seen before the HTTP starts the processing, we need to complete DHCP, we need to complete DNS, we need to complete ARP, and now we are ready to use the HTTP to send the HTTP request to the Google web server. Now, you know the HTTP request. Okay, again, when HTTP requests need to be sent, before that, a TCP connection must be established. Now comes the TCP, because you know HTTP, FTP, and then SMTP all uses TCP. That means what? That means this protocol needs to create a TCP connection that will establish a connection so that the segments will carry the HTTP level data. Okay. So since segment is sent, you know, three-way handshake, since segment is sent, and then the server will send back what? The acknowledgement, SYN ACK segment. Okay. See, SYN, it is called SYN ACK because SYN segment is also set, SYN bit is also set, acknowledgement is also set. So this is step 2 of TCP three-way handshake. So it will be sent back to the sender, and finally sender will send the acknowledgement. Actually, when sender sends the acknowledgement, it can transmit the data also. That's why it's said TCP connection is established. Now in the third step, sender will send an acknowledgement. By the time it can send also data. So this is the TCP connection setup. Now HTTP request will be created, and then this HTTP request will be sent through the TCP socket through transport layer. Okay, routing will transmit that HTTP request inside a packet through the routers to the final destination, that is the web server. Now web server received the request, web server will create a response with the corresponding file, and then it will send back with HTTP reply containing the web page. That means what? At the end of the response, it adds the raw bytes of the requested file. Okay. Now the browser in my laptop received the response, right? And then it shows, see, still web page is not shown, but now web page finally displayed. So we requested a web page, and then we got the web page. So this is how the entire example works. Any question, anybody? Clear or not clear? Any particular phase of the example, or anything you think not covered in this class? Is there anything?
No, sir.
Okay.
Sir,
So
but I have a question. Something to know, sir. From chapter 6, what type of question may come in the final, sir?
sorry. What type of?
Question may come in the final.
I am not sure, because I did not prepare the question yet. But what I can say, if you understand this example 100%, if you understand this example 100%, there is no reason you cannot answer 100%. So what type of question? Anything in this example I can ask. Like, for example, I can say, okay, this is a scenario. Now, list the protocols chronologically. List the protocols in order of happening. I can ask this type of question, right? This is one possible question. So if you say, okay, DHCP, then just your understanding, or I can give you a set of protocols also. Now order these protocols according to the occurrence in this scenario, in this example. Okay, so DHCP, then DNS, then ARP, then DNS again, ARP completed, then DNS again, then TCP, then HTTP, like this. This is one simple example, but if you understand everything, I think it will not be a problem. But the bottom line is, You have to visualize it. Please don't memorize. Don't memorize. That will not help. You have to visualize what is happening. Like you can just think without seeing anything, you know, okay, what is happening here? That is what we need. Okay, any other question? Anybody, any other question? Okay. So that is end of actually chapter 6, and that is end of the syllabus. But we need to do some hands-on. I will show you some example today, and then in the last class tomorrow, I will everybody should participate with me. I will discuss some examples hands-on. I will give you some exercises to solve, and then I will give you the solution. So tomorrow we have no theory to cover. We will do only in the first half we'll do only the hands-on things, and the second part floor will be open if you need to clear anything about the syllabus and the final exam. Okay, so today in the remaining time I just want to show you I just do you go to this interactive exercises section? I have already given the link. How many of you use this already? Okay, Shojol, Anis, Mohib. Only 3 I get here. What about others? Wow. See, they are very, very useful. Yes, Pratik, very good. There are many examples. What I think during the start of the yes, Tahalil, good. Tahalil, then Himel, very good, because you can get yes, Tanvir, you can get a lot of examples. The beauty of this interactive exercise is this. For example, you go to let me show one example. Network address translation. Okay, I am not going to cover network address translation right now, but just I'm showing you how it helps you. You can see a particular problem, and based on that you will get all the questions here. My suggestion is first try to answer the questions based on your understanding in the class, because I have several times I have mentioned you, if you don't understand the example, basic example from the textbook, it will have no use. You have to understand the basic example from my lecture and especially from the textbook, because all students are not that much interactive. So I'm sure they will not be able to do the entire thing only with my lecture. So go back to the textbook. That's why I'm saying, make sure you understood the basic example. If you can tell me, okay, I understood the basic example from the textbook 100%, then I can assure you there will be not a problem in this course. But are you sure? That is the question. Anyway, solve these questions before you can also show the solution. Solution is given. But if you first see the solution, then your understanding will not be that much, because your thinking is not there. You get the solution, then you'll be biased to memorize that solution. You will try to search the same example, same type of question in the exam. If the question is a little bit different, then you will be panicked and you will not understand. So try to solve the questions. If you have any problem, go back to textbook. Okay, I need to understand the basic. See, this 1, 2, 3, 4 we have covered the example in the textbook. So if you understand this, everything will be very simple. Now, what I like about this interactive exercise set is, suppose you have, okay, I am now I understand now what are the solution. I understand everything. Now I need more problems to practice. Sometimes it's very tough to create newer problems. What you can do? Just another problem like this. Click there. it will create a new problem with different context and different values for your practice. You click another problem like this, it will create a new problem. This is what I like about the most about these exercises, especially some of the topics, not exactly 100% of the topics covered by these exercises, but most of the topics are covered by these exercises, and some topics may be complex. So if you covered by these exercises, it will be very, very easy for you to understand. Okay, so those who did not go to this website, although I have given you, I think during the first or second class, I have given you this link. Anyway, now let me go back to the main home of this. Oh, sorry. Okay. Here, let us go to chapter 6. So chapter 6, we did not cover error detection and correction. Okay, we did not cover this, and then we did not cover random access protocols Aloha, but we covered collisions a little bit. Now let us first go through the link layer. This is very important. Link layer and network layer addressing and forwarding. Okay, so let us go through one example like this. Okay, so there is a scenario. You can see IP and MAC address. So every node has corresponding IP and MAC address, and there are some points specified 1, 2, 3, 4, 5, 6. And some nodes A, B, and C. There are other nodes, but some A, B, C, and D. Now it says, consider an IP datagram being sent from node B to A. So node B sends an IP datagram to A. Can anybody tell me? Okay, again, please use your message box. I don't need to, I don't want to, like every time some known faces give me answers, because I know they understand very fast, because I repeat many times. Sometimes this becomes boring for those students who are very serious. But what my goal is, I try to make all the class to participate. That's why I repeat many times. So I don't want only Muhib or Shajol or Pratik or some known faces to answer all the time. So please use your message box to answer the questions. If we need to send a frame from B to A, what are the points will be traversed? There are 1, 2, 3, 4, 5, 6 points specified here. What are the points? Very simple question. What are the points will be traversed if we need to send a frame from B to A? Give your answer in the message box. Yes, Shajal gives the answer. 1. I need at least 5 answers before I move. Again, the question, if we need to send, yes, Manik, 3 to 1. If we need to send a frame from B to A, what are the points the frame will traverse? Simple points. These are the points, just point. This is not a device. These are just points. Yes, Rajia, Mainul, Tanvir, Farhana. Very good. See, if you just participate, things will be very simple, easier. Make easy for you in the exam. But if you don't participate, it will not help. Okay, I got many answers. Definitely it's 3 to 1. Because if we just see the picture from B to A, first it will go through a switch connected to B, then it will go to the router connected to the switch, then it will go to the switch again connected to A, and then it will go to A. So it's definitely 3 to 1. Now let us see the questions first. What is the source MAC address at point 3? Write the answer. Already all MAC address and IP addresses are given. What will be the source MAC address at point 3? Muhib, you said router MAC. Okay, in the first thing, here you can use some symbolic name, no problem. You can use like MAC of B for faster writing. MAC of B, MAC of router or MAC of A, like this. But in the exam, if the question specifies all the IP and MAC addresses clearly, you have to write the real MAC address. You cannot write like MAC of B, MAC of A, MAC of B. Remember. So in this case, if you say, okay, this is MAC of router, then all the router interfaces MAC addresses are given. So write down the MAC like A, CB, CB, 90, EC, C8. Okay. Okay, I got two answers. Muhib says router MAC, and Shajal says MAC of B. Pratik says MAC of B. Mirja says MAC of B. Tahlil. Yes, Muhib, I think you did some silly mistake, right? It's a source MAC. Source MAC. What is the source MAC? So source MAC definitely B, because B sends data. So it will be definitely MAC of B. Very simple question this is. What is the destination MAC address at point 3? Very good question. Now you have to answer, what is the destination MAC address at point 3? Okay, when we say at point 3, actually you can think about the frame is passing through this point. There is no device, so it will not be changed, but it is passing through this point. So when frame is passing through this point, that means the switch is forwarding the frame to the router, right? In that case, what will be the destination MAC address? Shajol, you asked me the question, but let us see the answer from other students. Did you get my question? What is the destination MAC? What should be the destination MAC address when the frame is passing through point 3? Mainul says MAC of the router. Okay, one possible answer. What is there any other possible answer? Please participate. Your answer can be wrong, no problem. Doing wrong during the class much better than doing wrong during the exam. Why you feel shy to answer? Shajal says router MAC. Any other answer? Tanvir says MAC of the router. I will take two more answers before I move. Please participate. Hemel says MAC of B. See, MAC of B is the source, you already told, right? Tahalil says MAC of router. Actually, the answer will be MAC of router. But as I said, you should write AFCB, CB90, ECCB in the C8 in the exam, not only MAC of
It
router,
is
right?
small because I can see what is the MAC address. Very small.
Sorry, Mainul. Oh, it's very small. No problem. No problem. For the time being, it's fine. But just I want to make sure that you will see in the question, so you can add this. So, Rajia, this is not IP address. See, we are working with MAC address only. So you have written the IP address. It's not the IP address. So the destination MAC address will be definitely router of B, that is given here, AFCB90ECC8. That is connected to the switch part, connected to point 3. Third question, what is the source IP address at point 3? I think possibly Rajia given this. No, this is not also. This is not the IP address. Okay. Third question, what is the source IP address at point 3? This is very simple. What is the source IP address at point 3? IP of B, definitely IP of B. Okay. Yes, 128, 119, 52, 251. Right. Anis, very good. Mirja, IP of B, yes. But as I said, in the exam, you have to write the real IP address given in the diagram. Okay. So very simple. Source IP will be the source node. Fine. No problem. Then what is the destination IP address at point 3? Very good question now. Yes, Farhana, source IP is fine. Now question 4. What is the destination IP address at point 3? Destination IP address. Yes, destination IP address is IP of A. Okay. Yes. Anis says IP of A. Mainul says IP of A. Is there any other answer? C is not in the scenario. C is not in the scenario. So it will be possibly IP of A or IP of the router, right? But yes, Mirja, IP of A will be the answer because the source IP and destination IP will be fixed during the journey. We have told you, right? So the answer of the question number 4 will be IP of A, that is 128.119.69.150. Then do the source and destination MAC addresses change at point 2? So okay, it traversed through 3. Now the frame traversed 2.2. That means it already passed through the router. So the question is do the source and destination MAC addresses change at point 2? Or you can think about like this: when the frame moves from 3 to 2, will there be any change in the router made by the router? Okay, so answer will be yes or no. What will be the answer? Mainul says yes, Rajia yes, Anis, Mirja all yes. Okay, yes, the answer is correct. Definitely router, because we know router works at network layer. So router physical layer receives the frame signals, router data link layer receives the frame, and then it must remove the header. When it removes the header, source MAC destination MAC is gone, because it needs to give the packet to the network layer. Then network layer decides which interface it will go. So network layer decides, okay, I will forward to the interface that is connected to A. So definitely it will change. Yes. Now what is the source and destination? What is the source MAC address at point 2? What is the source MAC address at point 2? Muhib says router MAC. Any other answer? Anish says router MAC. Mainul says router MAC. Mirja router MAC. Any other answer? One more answer. Okay, Tanvir router MAC. Okay, see, I think many of you already understood the thing. See, this is the question. When you see this question in the final exam, if you see this question, I am sure you will answer this question first. If your concept is clear,
Sir,
no complexity. Yes.
when the packet leaves B and before it reaches switch, what is the destination and source MAC address?
Before it reaches switch at point 2.
Yes, sir. No, sir. Before point 3.
Okay. From B to point 3, right? As I
From
said,
B to switch.
from B to switch, actually nothing will change, because I think I have mentioned during the last section, right? Switch. A switch will change nothing, because switch will use the destination MAC only to know in which port to forward, right? But switch will not change any source MAC or destination MAC. So that's why if I actually place one more point between B and switch, suppose point number 7 and point number 3 actually will contain the same source and destination MAC. Did you get the answer, Muhib?
Yes, sir.
So switch will add nothing actually. Switch will just forward based on the destination MAC. So that's why, but router will change, because router's data link layer will remove the header before sending to router's network layer. That's why router must change. And so in point 2, the source MAC will be the router MAC, definitely. Router MAC means now not the previous one. This will be the router's interface that is connected to A. So the MAC is already given here, but again, this is router of MAC. What is the destination MAC address at point 2? What is the destination MAC address at point 2? So source is router's MAC, fine. And destination is actually MAC of A. Right, Mainul. Yes, Mirja. I think those who have understood the thing now very simple. So the destination will be A. Now the last question. Do the source and destination MAC addresses change at point 1 when it goes from point 2 to point 1? Yes or no? Mainul says no. Anis says no. Tanvir says yes. Okay, 2 more answer. I need to move. Muhib says no. Kalam says no. Farhana says no. Actually, Tanvir, the answer is no. Yes, Sojol. Because already I have mentioned, switch will not change anything in the frame. Switch will just receive a frame and based on the destination, forward the frame. So this is same at point 2 and point 1. Nothing will change. So if you now go through the solution, I think you can check. So for every question, try to get your solution first and then match with the real solution. If you have any confusion, you can definitely discuss with your friends, discuss with me during the counseling, no problem. See, the concept is now very clear, how addressing changes. So now if you want to practice just another problem like this, and you will see the contents might be the same, but the question might be different. So now B2, it's not changed yet. Okay. My net is becoming slow. Okay. See? So now B2D. So when you think about B2D, the points will change 3, 4, 5, but the idea will be same. So is it clear to everybody?
Yes.
Okay. So let us finish here today. Tomorrow we have another class, our last class. So try to bring some questions in the class, at least in the final syllabus from your own understanding. You don't have enough time, but at least so that we can discuss. And also
Sir.
those who did not try these interactive exercises, please try this. You will this will help you more. Okay, Mohib.
So,
Wait.
sir, what in TCP segment, what is the difference between ACK bit and ACK num?
Sorry again, Mohib.
So in TCP segment, what is
Yes.
the difference between ACK bit and ACK num?
ACT. Can you type the question? Maybe there are some noise. I cannot hear you properly. In TCP connection, the second part I did not hear. What is the difference between? Just write the words in the message box. Okay, acknowledgement bit and okay. See, acknowledgement bit is in the header. There are some control bits like SYN bit, acknowledgement bit, FIN bit. They are only used in the connection management. But the acknowledgement number is only part, not only part of connection management. Acknowledgement number is used in the connection management to acknowledge the sequence number of the other side. But the acknowledgement number is always being used to acknowledge the sender, the receipt of the segment. For example, if a receiver receives like up to byte number 1000, then it will send acknowledgement number 1001. So this is, in that case, when it sends an acknowledgement bit will be 1, but acknowledgement number will be according to the last byte receipt plus 1. Is it clear, Mohib? Yes. Whenever a receiver sends an acknowledgement, the bit will be 1. The header bit, the bit in the header will be 1, but the acknowledgement number is a different field. You can see that is a 32-bit number in the header, and that indicates the next expected byte number. So one is bit in the header, another one is the synchronized acknowledgement number according to the bytes exchanged between sender and receiver. Clear? Okay, very good. Anybody has any other question? Okay, if not, please respond to the attendance. Let me just stop presenting and stop recording.